Hi everybody, good afternoon. I'm doing now a room was released yesterday by TryHackMe, Network Traffic Basics. This room teaches a basic of network traffic analysis. Too much reading in this room, but to give you an idea different things so you can know what it is. As usual, I always say don't need to memorize, just know they are there so in the future you can learn deeper on them. First of all, let me clear this room. Info room is a free room, so everybody, if you have time, you can go and read all. I'll go to the lab later on this one. Task 1 introduction. Network traffic analysis (NTA) is a process that encompasses capturing, inspecting, analyzing data as it flows in network. Its goal is to have complete visibility and understand what is communicated inside and outside the network. It is important to stress that NTA is not synonym to for the tool Wireshark. It is more than that. It is a combination of correlative several logs, deep packet inspection, network flow statistic with specific outlined goals, which we will discuss later on. Knowing how to analyze network traffic is essential skill not only for inspiring SOC Level 1 analysts but also for many other blue and red team roles. Yeah, basically this room, yeah, it's good to know networking. When you see it, you can see the logs. So learning objective, of course, know what network traffic analysis is, know what it can be observed, know how to observe network traffic, know typical network traffic sources and flow. For example, pre-security, TryHackMe giving these two rooms. Let me see if they are free. The path of pre-security if you want to. I'm not sure if I did video for this. Okay, and then we have network security. Oh, this is premium, guys. I think I have video for it. You can check, guys. Network security essential. I thought I did this room. Any case, we'll check. So this is exactly task one. I'm going through fast. So task two, talking about what is purpose of network traffic analysis. Why should we analyze network traffic? Before we answer this question, let's look at the following scenario. Here, start with if there is rooms about DNS tunneling and beaconing. Usually DNS tunneling, you can always check them like you can see some random character happening in the subdomain. So you find a query because this is, for example, a way of attacker can accelerate data out of the host or the victim to his domain. So he send batches, and there's rooms like that in Wireshark. In TryHackMe you can see them. I think what's the name of the room? Boogie Moon 1 and 2 and 3. I think 1 or 2 do this scenario. So you collect all of them and then build unifying the file. Basic and DNS load the query and query type because ANT, this is what interested us. The host IP we can define the system sending DNS query. Destination IP we can use till like abuse IP. You can use various, of course, when you're doing analytic malware. You can you don't trust me. And then of course the famous Wish, if you are new to this special Vice total, the DNS log don't contain more information than that, so it's hard to draw conclusion based on the information alone. Okay, and this scenario is a prime example of why we need network traffic analysis. Firewall and other devices register DNS query and their response but not their content. Yeah, that's DNS DNS content. Threat actor could, for example, use txt record to send comment. I didn't worry about this one. I didn't have a room or CTF use this to compromise system. We can discover this by inspecting the content of DNS query. The packet capture fragment below show, for example, here you can see the normal domain DNS response. Always question one, that's question answer, and you see here. So this one should be. This is a base 64. Uh, I was doing talk the box this morning. Let's see what I'm doing here. Eco. What is this? A TryHackMe base 64 minus D. What is it? I love your curiosity. Yeah, he's laughing at us. TryHackMe. I love your curiosity. This guy is laughing. So this is not a command. It's like is I love your curiosity. Okay. Why should we analyze network traffic? Generally, we will use network traffic analysis to monitor network, check. Yeah, you guys, you can either don't twist boring you, but yeah, you can see the expectation. From SOC perspective, network traffic analysis help detecting suspicious or malicious activity, reconstructing attack during incident response, verifying and validating alert. So you can from here you can see the command, and here you can see what the data was exfiltrated. Um, Below are two more scenarios. Based on the log for end user system, the system began to deviate from its normal behavior around 4 p.m. UTC. Where is see 4 p.m. UTC? 9. Look, where is this 4 p.m. UTC? Analyze the network traffic going to and from the system. We found the suspicious HTTP request and were able to extract suspicious zip file. We retrieve an alert with DNS tunneling. Yeah, basically this is just scenario. There isn't too much example. The only lab we have this room. There isn't too much lab there. What's the name of the technique used to smuggle C2 command via DNS? They call it. I'm not sure. Yeah, it's a DNS tunneling and beaconing usually. That's I'm not sure why I'm confused at this part. Task 3, what network traffic can we observe? Of course, there's different layer in this. If you did Cisco CompTIA Network Plus, the best way we can observe in the network is by using the architecture implemented in nearly every device with network interface, the TCP IP stack. So you have a link, internet transport application header. This is the network traffic analysis. Lets you input so all these layers. Um, we have the application layer. That's what the HTTP, for example, are there. If you did network, for code snippet below, for example, here you can see if you do Wireshark, you see this. You get a GET request for zip. You get the user agents. Now send it. Like in this case, is curl. You send where the host, for example, and you get a response. Oh, he's not laughing to us here. A response, of course, binary zip file, and you can see there. Of course, we'll see also the size of it. So this is part of if you do Wireshark. Transport layer, the application data and header are segment and encapsulated. This won't remind me about Cisco. I did Cisco 1 when it was 1 and Cisco security. I remember this TCP flag sync length 60. And then we have firewall logs often include the source and destination. Firewall logs don't have too much detail, but they do this to catch the sync. For example, in these things, you can see sequence 0, and then you have acknowledge 1, then sequence 1, the acknowledge for 1, and then sequence, and then look how it jump. This usually, this is a sign as what we call it session hijacking. So it can be detected by analyzing the sequence number included in the header. If the sequence numbers are suddenly far apart further, investigation is warranted. So you can see this one out of range. It's like suspicious. And that's what explained this line, jump in sequence. Internet layer, when the transport layer send down a segment, this internet layer also add its header. This one, if you guys want to read this, because more quickly for the lab, in case somebody get assistance for it. But this is free room, guys. You can read. This is the header for the link layer down. That's the MAC address. We go into the IP. When the internet layer finishing encapsulation, the IP packet is sent to the link layer. The link layer add its header as well. Everybody add header, if I remember correctly. Containing more address information, most logs will display the source and destination MAC address. Yeah, like Wireshark. Okay, what happened here? Attacker spoof. This is the ARP. ARP spoofing. This room it was last week. what's happening? 192 is, you can see switching. You have this MAC address, then suddenly the MAC address change, and this is the IP address for the attacker. You can see is broadcasting. So here the attack spoof change, uh, relayed via attack. Who's this guy? 200. uh, Lucas P example in the task can answer the following question: what is the size zip attachment include in HTTP response? Note down in bytes. What's this? 10. Let's copy this lazy. 10 760. 10 Control V 760. Lazy way. Don't play with me, TryHackMe. Now, which attack do attacker use to try to evade IDS? We talk about here, they break down the packet. Why did I see it? This is the session hijacking. An attacker can create a tiny fragment to evade IDS or mess up a assembly of the fragment by using overlapping bytes range. So vice we call it fragmentation attack. I didn't see really rooms doing that. Most of the rooms they do DNS tunneling. Yeah, the fragmentation, it's in most. I didn't see someone can pull CTF and make that thing. What field in TCP header can be used to detect session hijacking? We talk about the session is the sequence number. I think it doesn't need an S if I remember. We almost built to the lab. Now the next task 4 is network traffic sources and flow. In the previous task we discussed what we can observe theoretically based on the TCP IPS stack. Practically it's more helpful to focus on specific sources and flow. A corporate network typically has some predetermined network flows and sources. We can group the sources into two categories: intermediary and endpoint. I don't remember these terms. The flow we can also group into two categories: north. This is my first time here. This north, south, and east, west. North-south traffic that exit or enter the LAN and then pass the firewall. East-west, it's like inside the LAN, include LAN that end to the cloud within the local area network. The source, we have intermediate sources. These are devices through which traffic mostly pass the endpoint or something, compute, I think that's it. Firewall switches, what pass? The IDS, IPS, router, access point, wireless LAN controller, all of that. The traffic that originated from this device came from services like routing protocol, BGP, OSP, remember this one, and management protocol, SMP ping, login protocol, and other. The endpoint is what we know them. There is device where traffic originates, and endpoint device talk and bulk of network bandwidth. Device that fall under this category is server host, wherever you see in your cloud resource, mobile phone, tablet, and many more. Flows. A network flow determined by the service available in network such as Active Directory. This north term, the north-south traffic. NS north-south traffic is often monitored closely as a flow. This is a lens stuff, RDP. This is, yeah, you can read, guys. Don't confuse too much about these things. Oh, the east traffic, we know them. So we're talking about what's inside your network. We have Kerberos, LDAP, file sharing, and print what file, SMB, IPP, what printer over network, router, switch, DSCP, R broadcast, internet, DNS, routing protocol messages, application communication, databases, connection, SQL, TCP, micro, backup replication, file replication, database replication, monitoring and management. This room too much reading on it. Flow example HTTPS. The HTTPS is well known. Web server, where is the client? This is the web server, this is the host. TLS session between host and web proxy. Where is the web proxy sit in the middle. You have a LAN, and then you go to the TLS session between web server and web proxy. When the web proxy receives the answer from the web server, it inspects the content and then forward it to the host if deemed safe. This is if you have a firewall there. Some people, they just don't have, they just treat through the router. External DNS, the DNS, the classic DNS. If you have a DNS internal, most companies, they don't have, they just use that external. The Kerberos is famous for Active Directory attack. This one, if you want to get confused in yourself here, when a host opens a share to, for example, an SMB session is set up. This is SMP. First authenticate is done through Kerberos. When a user is logged in the host, it authenticates with key distribution center. This is a, you can read a little bit fast, but if you want to learn it, do rooms specially for these things and practice. So they tell us, okay, router, firewall, SMB server, KDC domain controller, establish SMB session, request SMB service ticket. Okay, that's too much information. Which category of device generate the most? This is we already talked about it. That's endpoint. With an S or without an S device. Okay, let's see the S before endpoint, not the endpoint. Then before SMB session can be established, which service need to be contacted first for authentication. We talk about this is, where is SMB? External DNS, that's the Kerberos. But it would be, if we have too many labs, it would be nice, Wireshark and things like that. What does TLS? This is known. What does it stand for? Transport layer security. Now let's go to another. What we didn't finish? We finished. Task 5. How can we observe network traffic? Okay, that's a good question. Now that we have covered what we can and should observe in a network, let's examine how, as mentioned in the introduction, network traffic analysis focus on combining multiple sources of information. We can obtain this source from logs for packet capture, network statistics. Okay, logs are well known. Authentication log, for example, here SSH, Apache. So the log or event log in Windows. Full packet capture, you have this little toy here. That's nice, little Profi Shark. Install physical network tab. This is the lab. Configure port mirroring. Network tab is a physical device you place in line in your network. This device creates a copy of all network traffic that pass without affecting performance. So basically you copy it, but it's very big size. Port mirroring is more a software approach. Port mirroring is a software approach to copying packet from one port to on intermediate device to another that is attached to. So like this is what Cisco switch monitor 1 you create. This is general knowledge. What's best practice? Placement. This is key. Depending on which traffic we want to capture, we need to place a tab or configure the mirror at the right place. Duration for packet capture will require proportionate amount of storage. This is key if you want to read there. Now the exercise say open the static site and complete the two scenario by placing the tab in correct position and then covering the flag in the traffic. Fill the flag at the end. Okay, view on site. Tools, now that we know for packet capture, the tools, the famous is Wireshark, TCP, DAMP, IPS, IDS. Network statistics, another great way to find NetFlow. I don't know, NetFlow is protocol developed by Cisco, collect metadata. Okay, Internet Protocol flow info, IPFix. Internet Protocol Flow Information Export Protocol can be considered as the successor to NetFlow. NetFlow was initially a proprietary protocol from Cisco. This means that the protocol was designed for Cisco. Only from NetFlow v9 on did Cisco include templating, so other vendor could adopt it to their devices. Okay. As I said, this is just information general. Let's now go to where is the button? Oh, this is the button. Now if we do this, let's click here in full screen. Now in full screen you come here and then where first of all show instruction. He said your goal is to put network tab in the right place to capture network traffic, display capture traffic wherever. Start scenario, network tab device packet need start over. Okay, so we have devices here. They tell us we have FW. What do you mean FW1? We have WP1 is more like a user. What is FW1? Let's see what is FW. Can we zoom these things? Uh, oh, we have zoom here. Let me. Where is FW1? Let's do some tricks. Inspect. Just come here in this packer. No, inspect here. He said spam 0, spam 7, spam 8, 7, 8. Let's put this one 0. Oh no, not that one 0. Make it 15. So we can push that one up. Okay, now we can see this nicely. So where is this WP1? That's the user. Which one? This is like a switch. We have a DNS, we have a mail, we have Windows. I don't know what they are. Oh, suddenly I didn't see the. Where's the? We closed the. We messed up our. No, we didn't mess up. I just want to see what that one. FW1. Where is my? What I did now? Where is my? Disappear. We did 15. Let's make return it back. When you let's go back to 7. Reset progress. Refresh the page. Okay, it's back. Okay, let's not let's not play too much. I thought we can play too much. Inspect. Why that one doesn't have span 5? I want to kill that one. 0. Now if we kill that one by 0. Nope. I'm lazy. What I did now? Guys, let me not flip with you. I was trying to do something, but it seem doesn't want to work for me. So the first scenario say OX workstation has clicked on a phishing link and an HTTP request is initiated to download a malicious PowerShell file. Place the tab at the correct place to view web traffic. Find the HTTP response containing the PowerShell script and get the flag. So we assume this is the computer. The FW1 is 192.168. This is the W1. The F, where is that F1? SS SW. Oh, this one. This is not a computer. It looks like what? A firewall or something. Okay, so where we should place it? We can place it as closer as we can, because if we start here, you can see traffic is you go down and you go in there. Where is going? You going to okay, reset. So if I want to see what this one doing, what logically we should put it there. I think so. So we can put it there, the tab inside, so closer to it, so we can see what's going on. So and then it give us this. Now we're stuck here. We're not stuck. We can just do this. Inspect again. Sorry guys. Inspector. This element. Let me hide it. Display none. Okay, display none, and I can just come to this one. What is that column span 5? You just put it 15, and then we have a longer one. Let's do that now. So now the question is, because it's phishing, what we're looking on? Find HTTP response. So we're only looking for a response. Where is the response? So okay, this is the response. Look for which one we can find. There is no flag here, so he said PowerShell. So this is zip, so we're not interested on it. GS, well, where you open? We have GS, HTML, PNG, zip, site, profile. PowerShell, the question, phishing link to download the malicious PowerShell file. We have an app, but this is a Cloudflare asset, so it's not, doesn't look dodgy. Banner PNG site as this is an update from local bundle.js, and you can see install one PS. You can see now we have a, so if you go to the response, where is the flag? Get install PS1. Install PS1. What happened to the next this one? What's the source? 192.168.8. That's why it get confused me with the source, because the 192, the 3 is a Windows. The machine is WP1. I don't get the IP. Why the IP is this? I talk in Discord. I don't know. So we got download. What's the time? Not 29 in this one. Oh, this is the response. I'm confused. This is the GET request to download the PS, and that's the response for it. So, and the response gives us the flag, because we're looking for a PowerShell 1. So let's go to, I don't need that one, just we can get the PowerShell, so is this one. Now the next one, let's go back. Let's put our our 5, and then let's go back to, guys, you can do oh, I did remove it. No, we just need to refresh the page and that's it. Yeah, that's not a play. Before we move, we need to repeat. Let's get it where we put it there, and now let's proceed to the next one. The next one say a workstation has been compromised and malicious C2 instructions are being infiltrated via DNS text. So we're doing DNS text here. Remember the one that we start with. Um, so maybe it's this one or this one, something in DNS. Let's check the DNS. Place the tab correctly to capture and inspect DNS request and find the flag. Of course, now from a device we can guess where is our DNS. Doesn't see it here, but if you do here you can see it. It said SRV DNS, so this is our DNS. You can see this is the DNS, this is the mail, this is the Windows machine. So we have a DNS here. So logically, if you want to check what's going on, go closer to the DNS, what's happening there. So we are more logically come to the DNS part. So we're looking for DNS. So we make the tab next to the DNS in logically. So if I start, I want to see what's going in DNS. I put it there. Now you get these things again. You can just inspect that element. I'm lazy to think a better way to solve this. Display none, and then I can just here inspect 5. I just make it 15 and done. Okay, now we have this and we can zoom. So what we're supposed to do, we're looking for his is not out, is not exfiltration, is receiving. So we're more looking for DNS response, because we're looking for the response in text. So we're not looking for the queries, we're looking only for the response. So and then one of the responses, so which I'm not sure if this can we detect a strange name, strange domain, a response to news. So that's not a response for time windows. We can assume not dodgy. This one doesn't look dodgy. A response for news portal.local. A response for mail corp.local. Response to time corp. I'm not sure if this one is dodgy. A response to Windows authentication. Let's see if we can see anything dodgy at all. Boolean TCP. Try hack. Oh, this one look dodgy. Standard query to this one. C2 is already tell us the C2. It's a C2 name. And then we're supposed to get our flag in response to that. So we are more looking for response, and if any dodgy character come here, and you can see they play with the name TryHack, so they try to teach us to read. Be careful to see the names of the domain. And here we got our flag. And then we done as conclusion task 6. Now that we know what an NTA is, we need why we need it, how to capture network traffic, analyze it. We are ready to get hand-on with effectively analyzing network traffic using tool called Wireshark. Proceed to the next room to get started with basic of Wireshark. Which next room? I think, yeah, most of the room they will use the Wireshark for these things. Yeah, guys, sorry if I read, but it's a free room. Guys, you can read the detail if you want. Don't confuse yourself but too much about it. Oh, we didn't see this site. What is abuse PAD? uh, okay guys, thank you very much and have a good day.